Alright, let's get started on the solutions for homework 1. So, number 1 says determine whether either of these equations represent a sphere. If they do, find the center and radius of that sphere. So the first one it gives us is A. It's x squared plus y squared plus z squared minus 4x plus 2y minus 6z plus 25 equals 0. So the first thing I'm going to do is I'm going to try to complete the square to finish this. So I'm going to group the x's together. I have x squared minus 4x. I'm going to leave a space plus y squared plus 2y. Again, I'll leave a space plus z squared minus 6z. And then I'm going to go ahead and move the 25 to the other side right away after leaving a space. It was minus 25. Okay, so for this first term, I have to add 1/2 of this number squared. So 1/2 of minus 4 is 2, or is minus 2 squared. So that's plus 4 to this side, plus 4 to this side. Over here, half of 2 squared, that's going to be half of 2 is 1, so 1 squared is 1. So I add 1 to both sides. And then finally, half of minus 6 is minus 3. I square that. I add 9 to both sides. Okay, so here I chose this number specifically so that I can factor this as x plus 1/2 of this number squared. Or sorry, plus 1/2 of this number. So that's going to be minus 2 squared plus y plus 1 squared plus z minus 3 squared equals, so if we add these up, so 9 and 1 is 10, plus 4, that's 14, plus minus 25, that's going to give us minus 11. So here we see that we have something squared plus something squared plus something squared. So all of these are positive terms. So if we add them up, we're never going to end up with negative 11. So there are no points possible that satisfy this equation. Okay, so that means that this is not a sphere. Okay, so in the homeworks, I took off a couple points for some people if you didn't get the minus 11, like maybe like half a point or 1 point or something. Okay, but that was all you needed for this one. For B, it's the same thing, except we have, instead of 25, we have minus 22. So we have x squared plus y squared plus z squared minus 4x plus 2y minus 6z minus 22 equals 0. So I'm going to go ahead and do the same thing, except now I just have a minus 22 here instead of a positive 25. So I'm going to skip the next step because it's exactly the same as before. This is y plus 1 squared plus z minus 3 squared equals, so now when I move this over, I have 22 plus 14, which is 36. And so you might recognize this as x minus 2 squared plus y plus 1 squared plus z minus 3 squared equals 6 squared. So the center of this circle is when this is 0. Okay, so here we need x minus 2. So that tells us that the x coordinate is going to be at x equals 2. Here we're going to have y equals minus 1 and z equals 3. And the radius of this circle is going to be 6. Okay, so let's give this as a point. We have the point 2 minus 1 minus 3. That should be positive 3. That's an equal sign right here. So I'll put center equals this, and radius equals 6. Okay, moving on to question 2. Okay, so it says, number 2, describe omega, where omega is the set of all points x, y, z, such that x is greater than or equal to 0, z is greater than or equal to 0, and x squared plus y squared plus z squared is less than or equal to, it says 16, but I'm going to go ahead and write 4 squared right away. Okay. So here, what this region is describing is, let's look at it this way. So here we recognize this is all of the points inside of the sphere of radius 4 at the center 0. However, if we look at this at just the x and z, let's see, so we have, it should be x and this should be z, according to the right-hand rule. And y is going to be sticking up out of the board, or out of the screen. So here, if we were to look at the sphere just straight on from the side, right? So right here, we're looking straight on, and we can't even see the y-axis because we're looking straight along the y-axis. It's only going to be this region. Okay, it's going to be like a quarter of a sphere. Because, right, because x has to be positive and z has to be positive. So it's only describing like a quarter of a sphere where the x and z are positive. So if we were to look at this from the x, wait, x, y, I think I did those coordinates, these wrong, but whatever. Or okay, so in this case, the y would actually be into the board, but whatever. So here we have x and y. So if we're looking at this just from the x and y, what is this going to look like? So this is going to be looking at it from basically just straight on from the top. Okay, so we're looking down at the z-axis. So that's going to look something like this. Here, this is going to be minus, this is going to be positive 4, and this will be minus 4, and this over here will also be 4. And then let me just describe this in one other way. So if we have the y and z, and this is y. So here this is going to look like this. Right, so again, we're looking straight on, straight down the x-axis. So this is top view. This is a side view. This is a side view. Okay, anyways, it's going to look like this. Basically, we're just looking at a lemon slice from several directions. So the answers I was looking for was quarter or segment. Either one of those work, semicircle, something along that lines. Quarter of sphere with radius of 4, center at 0, and this would have been good enough. Some people try to do drawings, that's great, but this stuff can be hard to draw. So this is all I was looking for. I did take points off if you didn't include quarter of a sphere, because that was important. And then, so that was 2 points, 1 point for radius, 1 point for center. Next question. Number 3. We have the point P is 2, 3, 5, and Q is the point 1, 5, 7. Okay, so let me just, no, I can't draw in 3D. Okay, so to find the vector P, Q, right, the vector that starts at P and ends at Q, we need to do Q minus P. And we can think of these as vectors if we, because we can't actually add points, but if we just take the vector that has the same coordinates, we can subtract them and actually get this vector. Okay, so we're going to have 1, 5, 7 minus 2, 3, 5. Real quick, the order is important. If we had this the other way around, we would have the vector going from Q to P. Here we're having from P to Q. So we add these together, we add component-wise, we have minus 1, 2, 2, and that's my answer. It also asks for the norm of PQ. So this is square root minus 1 squared plus 2 squared plus 2 squared. So that's going to be square root of 1 plus 4 plus 4, square root of 9, which is 3. Next question. Number 4. We're given A, or so I guess, let me copy these down first. We're given that the vector A is equal to 2, 1, 5. Vector B is equal to minus 1, 1, 3. Vector C is equal to 1, 2, 8. All right, so question A says evaluate 2A minus 3B plus C. Okay, so that's going to be 2 times 2, 1, 5 minus 3 times 1, 2, 8 sorry, 3 times minus 1, 1, 3 plus 1, 2, 8. Okay, so let's go ahead and do the scalar multiplication. I multiply each of the coordinates, so this becomes 4, 2, 10. This is going to be plus, so I distribute this, so I have 3, 3 minus 9 plus 1, 2, 8. So we start adding the corresponding components. We have 4 plus 3 plus 1, that's 8. 2 plus 3 plus, I should have a negative. This should be negative right here. Minus 3 times 1 is negative 3. 2 plus 2 is 4, minus 3, that's 1. 10 minus 9, that's 1, plus 8, that's 9. And that's my resultant vector. B was just A plus B plus C. So this is going to be 2, 1, 5 plus minus 1, 1, 3 plus 1, 2, 8. I start adding. I have 2 plus 1, that's 3, minus 1, that's 2. 1 plus 1 plus 2, that's 4. 5 plus 3, that's 8, plus 8 is 16. And that's my answer. Okay, final question. Number 5. It says find alpha so that 2 I hat minus 3 j hat plus 4 k hat and minus 4 I hat plus alpha j hat minus 8 k hat are parallel. Okay, so we know that two vectors, I'm going to call this one A, and I'm going to call this one B. So I know that two vectors are parallel if either A equals some number times B, or even the other way around, right? It doesn't matter. It could also be B equals lambda A. These are like completely equivalent. Basically, if one is a scalar multiple of the other. Okay, so what do we notice? Here we see that, so we want this to be the case. So we have, I'm going to write this in row form. So this is 2 minus 3, 4. So we want this to be equal to, we want lambda times this to be equal to minus 4 alpha minus 8. So if I distribute this, I actually end up with kind of 3 smaller equations, right? Here I have 2 lambda equals minus 4, and then I have minus 3 lambda equals alpha, and lambda times 4 is equal to minus 8. 4 lambda equals minus 8. So I divide both sides by minus 2 here, and I get minus 2 equals lambda. And I plug that in here, so alpha equals minus 2 times minus 6, times minus 3, which is positive 6, which is my answer. So some people just kind of did the ratio, so they looked at 2 over minus 4 should be the same as minus 3 over alpha, which is true, but a common mistake with this was people also wrote this. Okay, and this is wrong because I cannot divide by a vector. So the idea would have been fine, but I can't divide by a vector. Okay, so I don't want to see vectors in denominators. All right. Oh, the average for this in terms of number of points was just shy of 16.